Hello everyone, in this video we're going to be looking at percentage composition by mass. So we're just trying to find out the percentage of an element in a compound using the mass numbers or the relative atomic mass numbers. Now those of you who've seen my previous video on relative formula mass will recognize these compounds because these are the exact same compounds that are used in that previous video. If you haven't seen the video on relative formula mass and you don't know how to do that, please watch that video first because it will make your life a lot easier when doing these calculations. Link to the video can be found in the description box, so if you just click that, it will take you straight there. So our first example is the compound CO2. This question wants us to work out the percentage of carbon by mass in CO2. So I'm only going to do this for this particular example. I'm going to work out the relative formula mass of CO2. So I've got 1 carbon and 2 oxygen atoms. So I'm going to use the mass numbers. So if you look down here, carbon's got a mass of 12, so I'm going to write this down, and each oxygen atom has got a mass of 16, but we've got 2, so I'm going to do 16 twice, and we're just simply going to add up all these numbers and we're going to end up with our relative formula mass of 44. So that's the first step. Now out of that 44, carbon accounts for 12. So there's only 1 carbon. So we're doing 12 over 44 and then timesing that by 100 to get our percentage. And we should get an answer, if I round it to 3 significant figures, an answer of 27.3. Now the calculator gave me 27.27 recurring, so that's the reason why I've just rounded it off to 3 significant figures or 1 decimal place. Our second example is magnesium sulfate. This question wants us to work out the percentage of oxygen in MgSO4. Now I've already worked out the relative formula mass RFM to be 120. Now we've got 4 oxygen atoms and we need to account for all 4 of them. 1 oxygen atom, as you can see down here, has a mass of 16. So if we do 16 times 4, we should get 64. Now the RFM, or the mass of this whole compound, was 120. So we'll do 64 over 120 times 100. And if you round out to 3 significant figures, you should get an answer of 53.3%. This next example, example number 3, involves the use of brackets, so it's slightly more challenging. This compound here, FeOH3, is called iron hydroxide. Now in my previous video on relative formula mass, I covered the use of brackets. So this 3 here means everything inside the bracket is multiplied by 3. So that means there's 3 oxygens and 3 hydrogen atoms. It does not affect the Fe at all. So I've calculated the relative formula mass to be 107. Now this question wants us to work out the percentage of hydrogen in this compound. So because we've got 3 hydrogen atoms, each hydrogen atom has a mass of 1. So we're going to do 3 over the total, which is 107, or RFM, sorry, and then multiply that by 100. If I just check on the calculator, that gives me an answer of 2.8%. If I round that to 2 significant figures. So hopefully you're still with us and not bored out your mind. Our last example is slightly more challenging. It wants us to work out the percentage of oxygen in a more complex compound, Fe2SO4 which is iron sulfate. Now the relative formula mass of this compound I've worked out to be 400. And the question wants us to work out the percentage of oxygen in this compound. Now, because we've got 12 oxygens, we've got 4 here inside the bracket, but outside the bracket there's a 3, which means it's 4 times 3, so that's 12 oxygens. If you do in a calculator 12 times 16, which is a mass of 1 oxygen, you get an answer of 192. And we've got to divide that by the RFM of this compound, which is 400, and then multiply it by 100 to get our percentage, and we should get an answer of 48%. So 48% of this compound is oxygen.